There is a formula for calculating out the value of sine A plus B if information is known about angle A and angle B. Unfortunately, that formula is not, contrary to popular belief, sine A plus sine B. That is actually most definitely not true. It would be nice if it was sort of like a distributive property type thing, but that's not how it works. And you can see that even for just this example here, sine 30 is 1/2, sine 60 is radical 3 over 2, and sine 30 plus 60 is equal to 1, but sine 30 plus sine 60 is 1/2 plus radical 3 over 2, which is bigger than 1, so it's just not true. It would be nice if this were true, but it's not. It's more complicated than that. First, I'm going to show you what the formula is, and then I'm going to derive the formula afterwards. The formula is not very intuitive when you just see it. It's actually kind of complicated, and it's not at all obvious why this is true. But the formula is sine A cosine B plus cosine A sine B. So there's actually 4 components that we need. And for example, let's say I had to calculate at sine 75, and I notice that 75 is 30 plus 45, and those are good numbers because I know sine of 30, and I know what cosine of 30 is, and I know what sine of 45 is, and I know what cosine of 45 is. Sine of 30 is 1/2, cosine 30 is radical 3 over 2, sine of 45 and cosine 45 are radical 2 over 2. So according to this formula, it's sine 30 cosine 45 plus cosine 30 sine 45. And these are the 4 things I have here. So sine 30 is 1/2, cosine 45 is radical 2 over 2, cosine 30 is radical 3 over 2, sine 45 is radical 2 over 2. This becomes radical 2 over 4 plus radical 6 over 4, which is radical 2 plus radical 6 over 4. That is the exact value. Turns out to be 0.9659 approximately. And if you type sine 75 into a calculator, that is what it will say. Famous test question on this is they don't say what A is, but they tell you that if sine A equals 1/3 and sine B equals 1/4, what's the value of sine A plus B? Well, it's sine A cosine B plus cosine A sine B. But only 2 of those 4 things are given to us. So we need the other 2. And the other 2 are easily calculated because we have an identity that cosine squared theta is 1 minus sine squared theta. And actually implied in here is that A is an acute angle, and so is B. I'll just tell you that. So I can calculate out cosine theta as the square root of 1 minus sine squared theta. So that means that cosine of A is the square root of 1 minus sine squared A. But sine A is given to us, so it's 1 minus 1/3 squared, which is 1/9. So we end up with square root of 8 over 3. Okay, square root of 8/9, which is the square root of 8 over the square root of 9, which is, we could even turn to 2 root 2 over 3. That's just what cosine A is. Cosine B, let's give ourselves some room for that. Cosine B is going to be the square root of 1 minus sine squared B. Sine B is 1/4. So it's the square root of 1 minus 1 over 16, which is the square root of 15 over 16, which is root 15 over 4. I notice I wrote a half here. I was supposed to write 1/3. Here's our answer. If we simplify that a bit, I'll just do it over here. I get common denominator of 12, and the numerator is radical 15 plus 2 root 2. So that's a sort of popular question where some people just add together the 1/3 plus 1/4 and don't get the correct answer. I could have other known information. Actually, it's easier if I tell you sine A and cosine B, because you're not as tempted to add them together. Sine A plus B is sine A cosine B plus cosine A sine B. Well, sine A is given to me as 2/3, and cosine B is given to me as 3/5. So that's 2/5 right there. But the other two pieces aren't given to me, but I can calculate them. Cosine A is the square root of 1 minus sine squared A, which in this case is the square root of 1 minus 4/9, which is square root of 5/9, which is square root of 5 over 3. And it's also true that sine A is 1 minus cosine squared A, so I can do sine B is the square root of 1 minus cosine squared B, which is square root of 1 minus 9 over 25. That one actually ends up becoming 4/5. I should leave these 3's in here. So I have 6 over 15 plus 4 root 5 over 15 is 6 plus 4 root 5 over 15. That's the exact answer. Now, where this formula came from where is it? This formula, true formula. There are different ways to prove it. This is a diagram I really like. Here's a nice unit circle, and this is angle A here, and this is angle B. I'll just call it alpha and beta. So this red line here is sine alpha, and this blue line here is cosine alpha. That's because the hypotenuse here is 1. On the other hand, this line here is sine beta because this hypotenuse is 1. And this line here is cosine beta. So we have these 4 line segments identified. Now, a really important line segment, which I'll make gray, is right here. This thing, whatever that is equal to, is sine of alpha plus beta, because we have this sort of alpha plus beta angle and the hypotenuse is 1. So this is like the goal that we're after. And the trick to this question is to draw in this little line here and realize that this gray line is this blue piece plus this green piece, or I could put the green piece over here also. Now I'm going to focus first on that green piece. I'm going to take this triangle here with the alpha in it and just move it out for a second. So what do we know about this triangle? Well, the only thing we actually know is the hypotenuse, believe it or not. The hypotenuse is this yellow line. So the base of this top triangle here is also the hypotenuse of this other one. So I have cosine beta over there. And that makes this green line in general, it's going to be hypotenuse in a triangle like this, where this is R sine alpha. In this case, R is a more complicated expression, so it's cosine beta times sine alpha. Too much stuff here. And now I've identified this piece here as cosine beta plus sine alpha. Now I'm going to focus on this red triangle here. Make it bigger. One thing we know about that triangle is that its hypotenuse, which is over here, that was the opposite side of, this is angle beta. So that side there, which is also over here, is cosine beta. Now, this angle alpha is here, but it's also in a bunch of other places. And one of them is this little tiny angle right over here because of alternate interior angles. Now it's a little tricky to see why, but this angle up here is also going to be angle alpha. And the reason why is, see this little tiny right triangle? It has alpha and 90 minus alpha over here. And this bigger triangle has that 90 minus alpha, and it has this right angle here. So there might be some other reasons why, way to prove that. But I'm looking now at this kind of medium triangle that I'm outlining here. Okay, so that's this. So if this is alpha, the hypotenuse of this triangle is cosine beta. So the this thing's actually sine beta. It's the opposite of beta in this triangle here. Sorry about that. So this line over here is the adjacent. So if this was R, this would be R cosine theta, but it's not R. It's sine beta is the hypotenuse. So it's sine beta times cosine alpha. And when I notice how that is a piece of the formula, this is the other piece, because these two, erase everything now. So this thing here, sine beta cosine alpha, and this piece here is cosine beta sine alpha, and together we end up with the formula, which I'll write again: sine A plus B sine A cosine B plus cosine A sine B. Sometimes they call a visual proof like this a proof without words, and it's a good formula. That's a pretty interesting proof of it. There are other proofs of it. This rectangle has a lot of relationships in it. So they have this hypotenuse here. So if this is angle beta and this is angle alpha, and we have this one here, we can make a right triangle, this one here, that has cosine beta and sine beta as its sides. And then if we kind of just put a rectangle around the whole thing like that, the hypotenuse for this blue triangle is cosine B, so this piece here is sine A, I'd probably write it as cosine B times sine alpha, and the adjacent is hypotenuse times cosine alpha, and the hypotenuse is cosine beta. On the other hand, see there's an alternate interior angle thing going on here, so if this is alpha plus beta, so is this, and this is still 1 is the hypotenuse, so this piece is sine alpha plus beta, and this is cosine alpha plus beta. Actually, we get more formulas out of this picture. In this other blue triangle, and we can actually see a little better, alpha this is complementary to this one. But so is this, because together these three angles make 180 degrees. So these two together make a 90 degree. So in this triangle, this blue one here, it has a hypotenuse of sine beta. So the adjacent side is sine beta cosine alpha, and the opposite side is sine beta sine alpha. And since the height of this rectangle can be thought of either as sine A plus B or as sine A cosine B plus cosine A sine B. And here is yet another proof without words. It's very similar. Basically, they started with this triangle here with hypotenuse of 1 and angle beta. And then they drew this vertical line down and a horizontal line. And they called this angle alpha. And what we see here is that here's alpha. So sine alpha is, this is sine alpha plus beta because this is hypotenuse 1 and this angle is alpha plus beta. Actually, this picture is a little harder to create than it seems at first glance. So maybe I start this way. I have my alpha and beta angles, and I put them together and make this triangle. So that's 1, and this opposite side is going to be sine alpha plus beta. Now, if I make an angle beta up here, and I just kind of extend it down, and then I extend this line, this is going to be alpha because there's a rule that the exterior angle of a triangle is the sum of the two remote interiors. So if this is alpha plus beta and this is beta, that would have to be alpha. And now I have a lot of right triangles in this picture. Now, because this is beta and this is 1, this is cosine beta sine beta. Here I have sine alpha plus beta because of this triangle. So I got a lot of right triangles in this picture. And then I also have the very large triangle, namely this one. So we can say that sine alpha is opposite over hypotenuse. Well, the opposite is sine alpha plus beta. And the hypotenuse is cosine beta. And this last part's a little tricky. Just focus on this red triangle now. From that red triangle, we have this angle alpha. So I can say kind of on the side that sine alpha, using this red triangle, is opposite actually better than that. I'm dealing with the opposite and the adjacent, so I could say tan alpha is equal to opposite, which is sine beta, over adjacent. And this adjacent side, let's say I don't know it yet, so I can say adjacent side equals sine beta over tan beta, but tan is sine over cosine. This is tan alpha, not beta. So the adjacent side turns into sine beta times cosine alpha over sine alpha. So that's a lot of work. It utilizes tangent, and that's why they have this. And then I can finish up, and that piece ends up over here. Sine b cosine alpha over sine alpha. And then if you take that thing and you basically multiply, cross-multiply, you end up with sine A plus B on one side, and on the other side you get sine A times cosine B, and this sine A cancels out with that one. So that one was actually a mouthful. It definitely required, this part here was the trickiest way. Maybe there's some other way to get that. Well, main takeaway from today's lesson, though, is the formula. sine A plus B equals sine A cosine B plus cosine A times sine B, and not sine A plus sine B.